Hello everyone. In this video, we will discuss hyperconjugation. Before we understand what is hyperconjugation, first we understand what is sigma electron and pi electron. Suppose this is a compound and the structure of this compound. This is sigma bond and this is pi bond. This is sigma bond. Pi bonds contains pi electrons and sigma bond contains sigma electrons. We understand what is alpha carbon and alpha hydrogen. Alpha carbon, first carbon attached to a functional group. This is a functional group, okay, and this is a alpha carbon. This carbon has 3 alpha hydrogen. Let's see another example. CH3, CH double bond CH, CH3. This is the functional group. This is the alpha carbon and this is also alpha carbon. 3 alpha hydrogen this carbon and this carbon have also 3 alpha hydrogen, means this compound has 6 alpha hydrogen and 2 alpha carbon. Let's see another example. This is alpha carbon and this alpha carbon has 3 alpha hydrogen. Let's see another example. Okay, this is alpha carbon and this is also alpha carbon. This alpha carbon has 2 alpha hydrogen and this alpha carbon also has 2 alpha hydrogen. We understand what is hyperconjugation. Alpha hydrogen plus sigma electron. It is a hypothetical process. It does not occur in real life. Positive sign show vacant orbital. Suppose this carbon has positive signs, means vacant orbitals. We write this carbon like this. Suppose this sigma electrons transfer this p orbitals. Okay, we find this structure. Okay, suppose this sigma electron transfer this p orbitals. We find like this structure. This sigma electron transfer this p orbitals. We found like this structure. This is resonance structure. A question arises here, why hyperconjugation is known as no bond resonance? Answer is, there is no bond between carbon and hydrogen atom. Next question is, why hyperconjugation is known as sigma pi resonance. Answer is sigma electrons are shifted to a vacant p orbitals. This electron is shifted to vacant p orbitals. Resonance occur sigma pi resonance. Some important point to determine the stability of a compound. Alpha hydrogen increases, hyperconjugation increases, stability increases. Let's see some example. This compound has 9 alpha hydrogen, 3, 3, 6, 3, 9, 3 alpha carbon and 9 alpha hydrogen, and this compound has 2 alpha carbon, 6 alpha hydrogen, and this compound has 1 alpha carbon and 3 alpha hydrogen, and this compound has no alpha carbon, no alpha hydrogen. Stability like this. This is the most stable and this is the least stable compound. Let's see some example which compound has hyperconjugation possible and which compound have hyperconjugation is not possible. This compound is aldehyde. CHO means no alpha carbon या alpha hydrogen, and this compound has carbocations means alpha hydrogen and alpha carbon means hyperconjugation is possible, and this compound is alcohol. And hyperconjugation is not possible. This compound alkene, double bond hyperconjugation is possible, and this compound also have free radicals, hyperconjugation is possible. Hyperconjugation possible in these three compounds means carbocation, alkene, free radical. In three type of compound hyperconjugation is possible. No bond resonance structure equal to number of alpha hydrogen. Basically, hyperconjugation is the delocalization of electrons through overlap between the p orbitals occupied by the odd electron and a sigma orbitals of the alkyl group. Delocalization of sigma electrons. Through this overlap, individual electrons can to an extent help bind together three nuclei, 2 carbons and 1 hydrogen. This kind of delocalization involving sigma bond orbitals is called hyperconjugation. Greater the number of alpha hydrogen in an alkene, larger the number of hyperconjugation structure and consequently greater is its stability. Thank you so much.